And so now let's get into the fundamental theorem of calculus. It says this: if the integral from the bounds of a to b, or on the interval a to b of f of x dx equals, and here's where we do a little substitution. It'll equal the antiderivative solved at the value b minus the antiderivative at the value of a substituted in. So that's how we're going to solve these integrals without using technology. It's the antiderivative, the difference of the antiderivative evaluated at b minus the antiderivative evaluated at a. The top of the integral minus the bottom, or the right bound minus the left bound. And it'll be represented using this form. Okay, so here we go. Use the fundamental theorem of calculus to find the area of the region between the graph of y equals 5x to the fourth and the x-axis. And so before we actually even do this, let's just make sure we get the right answer. Let's see what the calculator has to say about this one. So I'm going to open this back up. We're looking for the integral, or on the interval from 2 to 4 of 5x to the fourth power. So that is what we're looking for. And I need to zoom out here. It looks like I need to be up at least, let's just say 900. And I'll make this negative 100 so we can see below. And I don't need to worry about going so far left or right. So I'll zoom in, and that's the integral we're kind of looking for here. There's, well, there we go. So I'm looking for the interval, or the integral going evaluate from 2 to 4. So that's basically what we're going to do. This says the answer is going to be 992. Let's see if we get the same thing. So if f of x equals 5x to the fourth, then our antiderivative would equal 5x to the fourth plus 1, which 4 plus 1 is 5, divided by 5. Whoops. Which will just be x to the fifth. And normally we would add the plus c, but when you're evaluating an antiderivative, you don't have to worry about the plus c. You don't need that. And so, f of x evaluated from 2 to 4 is going to equal, what we'll do is we'll plug in a 4 first, 4 to the fifth power, and then subtract 2 to the fifth power. So I took this equation and I substituted 4 into it, and then I'm going to subtract and substitute the 2 into it, and we'll evaluate this. Four to the fifth power minus 2 to the fifth power, and we do in fact get 992. That would be our solution here. Now part B, we're going to evaluate this function here. So let's first start with the antiderivative. So f of x equals negative x squared plus 6x plus 9. So the antiderivative, we got to go to the third power. So it'll be negative x to the third divided by 3. Plus this will go to the second power, 6x squared divided by 2. And this is like x to the 0, so it'll become 9x to the first power, which means I divide by 1. So what we'll do is we'll evaluate this antiderivative. Again, we don't have to worry about the plus c. When you evaluate your antiderivative, you don't have to worry about that, from 0 to 6. So I'll plug in 6 first, negative 6 cubed over 3 plus 6 times 6, and I should have probably put that in parentheses right there, squared over 2. I didn't reduce this. Let's reduce what we can reduce right here to a 3. And okay, which is going to now reduce, whoops, this portion right here. Where now we'll have, and I'm going to fix this over here, that looks pretty ugly. Put that there and the negative up front. Okay, we will now have 3 times 6 squared plus 9 times 6. And then we need to subtract a whole group. So I'm going to put that in parentheses. It'll be negative 0 cubed. I don't need to worry about that in parentheses. Plus 3 times 0 squared plus 9 times 0 to the first power, which all of this, anything multiplying by 0, which each 3 terms are multiplying by 0, will disappear. And so that'll just be 0 across. And so this ought to be our solution here. Let's see what we get first using, just start typing in what we think that algebra should look like. And we'll test our work. Divided by 3 plus 3 times 6 squared plus 9 times 6. This is giving me 90. Let's determine now if that's totally accurate. We have negative x squared plus 6x plus 9 as my original function. And I'm looking at the integral evaluated from on the interval 0 to 6. And it does say it's 90. So we got that correct. So the answer here would be 90. Now it's your turn. You can either use the algebra using the fundamental theorem of calculus or a calculator to come up with your exact answer evaluated on the interval from 0 to 2 of this function. Pause the video if you need more time.